Pass everything on. Got 76 limit governments.
Alrighty, first problem is a long division. And probably the one that'll give most of you the most trouble, so you might wanna hang in there with this guy right here. So we're gonna start with that, and we're gonna put our x plus 1 right here. Of course, we have to put what we're dividing by. That would be x to the 4th. Then we have minus 4x cubed. We're missing the x squared, so make sure you put 0 x squared. We're missing the x term, so we're gonna need another 0 x. And then we have plus 6 to finish up. So first thing, don't make that mistake. If we're missing those powers, what do you gotta put in there? You gotta put that 0 in there. Does everybody remember that? Okay? All right, we're ready to roll straight down. I'm gonna multiply by x to the 3rd. That would give me x to the 4th. That would give me a positive x to the 3rd. Of course, these signs need to change, so that's gonna become negative, which will make a 0 here. That becomes negative, which gives me negative 5 x cubed. Still have 0x squared, bringing down all the rest of this stuff. Now remember, we just keep doing what? Keep repeating that process, don't we? What have we got to multiply x by to get negative 5x cubed? And that would be negative 5x squared. That, my friends, gives me negative 5x cubed. That would give me negative 5x squared. Again, this becomes positive, which makes that 0. This becomes positive, which gives me positive 5x squared. 0x plus 6. Keep on rolling. I'm going to multiply by positive 5x now, because 5x gives x times x gives me that 5x squared. 5x times that 1 gives me plus 5x. Remember, these signs change. That becomes 0. So now we're looking at negative 5x plus 6. We're getting close. We're going to multiply by negative 5 now, because that'll give us negative 5x is what we're looking for. Negative 5 times 1 would give me negative 5. But again, that becomes positive to give us 0 here. That becomes positive, which gives us 11. So plus 11 is our remainder over what we divided by. X plus 1. Good old long division there. Questions on the long division? Feeling better about those? You've been practicing, hopefully. All right. Scooch on down to synthetic substitution or synthetic division here. I might just pull that up and put it right above it, just so we have a little more room there. All right, remember we got to set this equal to 0 and solve, so x is positive 1. So 1's going to go in there. Make sure we have 2. Oh, we're missing the cube, so we're going to put a 0. Then we're going to have 5. We're going to have negative 1. And then positive 4. Bring down the deuce. 2 times 1 is 2. Add that down, we get 2. 2 times 1 is 2 again. Add that down, we get 7. 7 times 1 is 7. Add that down, we get 6. 6 times 1 is 6. Add that down, we get 10. So there's our coefficients using synthetic division. We started with a degree of 4 up here, so it's going to be x to the 3rd plus 2x squared plus 7x plus 6 plus 10 over what we divided by, x minus 1. There's a lot of stuff right there, and that's some beautiful stuff in there, right there, right up there with handing out coffee out in the parking lot right now. Looks pretty popular. There's lots of people out there. I thought it was just for teachers, but it looks like students are going out. Anybody else?
It's for juniors and seniors too.
How? You guys have to pay? Juniors and seniors to pay?
Yeah.
What's the cost?
Well, there's a bunch of stuff. They have high and cool drinks. They're from like $3 to $5.
Where?
Do they have like a, if I went out there, I don't like coffee,
You
or
stand
something
up.
for me.
Yeah, like they have smoothies,
Or like,
tea,
you'll see
hot
it.
chocolate.
It's like
and
a little
coffee.
stand.
Where's that there?
It's like a giant cardboard box.
Why is it there?
They're selling coffee.
Why?
Because they wanted to.
Who set that up?
Yeah. Why is it there?
Somebody. All right, here we go. Number 3 is synthetic substitution. Just like synthetic division, we're not gonna put the X's in there. All we're really concerned about is our remainder, okay? So again, if we're missing some numbers, we better take care of that. So we're gonna put 2 in the box, because that's already solved for. I've got 7, I'm missing the cube, so I gotta put a 0. -5, -5, -10. Again, you see a theme, I've been coming along here to make sure everybody knows we gotta put those zeros in if we're missing, right? All right, bring down 7, 7 times 2, 14, that gives me 14 there. 14 times 2 gives me 28, which gives me 23 here. 23 times 2 gives me 46, which puts me at 41. 41 times 2 gives me 82. That puts me at 72. So I'm looking for your answer to look like this. P of 2 equals 72. That's your remainder. We're looking for an answer of P of 2 equals 72, and I hope that you write it like that. That's what I want to see. Feel good about that one? So we have a long division, synthetic substitution. Okay, next is the grouping. Okay, must have 4 terms. It does. We're gonna group this thing up, this first part, we're gonna take out a b squared. We're gonna be left with 4b plus 3. Here we're looking at taking out -4, which would leave us with that same thing. Remember, we gotta try to get the same binomial there. Rewrite b squared minus 4 and 4b plus 3. Now, difference of perfect squares, isn't it? Remember, if it was b squared plus 4, I leave that alone, okay? Plus, the sum of squares I cannot factor. But the difference does factor. The b minus 2 and b plus 2. If you were to FOIL b minus 2 and b plus 2 out, you would get this, okay? Because the middle terms would cancel. We still have that other thing along with it, 4b plus 3, so don't lose sight of him being along there also.
So you can only do that when the first group is positive, right? Or negative.
Negative. If the difference, it's a difference. Negative perfect squares you can do. Positive perfect squares, can't. Factor. Okay, we got another grouper down here, so let's look at that guy, and then we'll go back up to the perfect cubes in a second. This grouping down here, I think I'll take out x squared, which would leave me with 2x plus 1. I took out x squared, it was x squared, so you gotta hold that spot with that 1, you remember? That back from algebra? How about negative 36 here? That would leave me with 2x plus 1 also. Aha! Looks like I have the difference of perfect squares again. Now just remind you, that's not always the case. It might not happen, okay? So now I'm ready to factor that to x minus 6, x plus 6, and now we're down to 2x plus 1 coming along, and there is your factoring of number 6. Anything there? Good old groupings. How are we feeling about those? Okay? All right. We're down to this last one here, perfect cubes. I'm going to clear myself some room so we can get that done. Come on now. Cooperate there, please, thank you. Okay, this formula is gonna be A minus B, A squared plus AB plus B squared, and oops, B squared there, oops. Let's fix that, squared needs to be on the inside. All right. So we can always look for a GCF, and this guy does have one. So we need to take out an X. And we're gonna be left with 27y cubed minus 64. Well, 27 and 64 are those perfect cubes we're looking for, aren't they? We gotta figure out what our A is. Our A is the perfect cube of that first term, 27y cubed, which would be 3y. Our B, perfect cube of 64, which is 4 times 4 times 4, which of course is 4. Now, don't forget that X still needs to be out front. It's GCF, we took it out already. My A is 3y minus 4. Now, here's the part students forget a lot of times. They forget to square this part. Okay, so A is squared, 3y times 3 would be 9y squared. 3y times 4 would give you plus 12y. And then 4 squared would be plus 16. There you go. Feel ready?
So how did you get the 3 and the 4? Like, how did you do that?
How do I get the 3 and the 4? 3y and 4, okay, that's the perfect cube, 27. So I'm looking at the cube root of 27y cubed.
Oh,
Does that help you?
okay.
And
Yeah.
I'm looking for the cube root of 64. Everybody good? Fantastic. That's it. Thanks for today. Chill out a little bit.
Go change it.
Yeah.